Alright, another draft physics video presentation. DraftScience here on YouTube. Comments, but I will go somewhere else likely. Use these merely as fodder for better conversation. Something like that anyway. So I do want to go back to some previous comment that I kind of went over quickly, but anyway, we'll see how that goes. I guess the point is the comments aren't relevant enough. Sorry. Not good enough. So I'm going to go back to this comment. You are sad. Ken Wheeler is very smart. So this comes up in other comments and other places. It's not a smartness competition. And it's not a who possesses the most trivia. That's really not a good test of intelligence or utility of knowing, having a brain that is able to do process the world, answer questions, let's just say. The real point is to answer questions right? There should be kind of a high penalty for how many wrong answers you provide. Yes, you provided lots of right answers, but if the percentage of wrong answers is high, then the quality of the intelligence is suspect and of no value, or little value, or even a negative value in the sense that the premises are all wrong. So it's sort of like you make the argument there's some good values in religion, but the bullshit that goes with it is just so preposterous, and the reasoning is so illogical that it almost ruins any good value, because people don't understand that it's just kind of logical to expect to get what you give. If you give the world shit, you should expect shit back. That's just a logical thing. You don't need to think that God says so. You just need to think, yeah, that's just logical. It's like if I throw my garbage out the window and everybody else thinks it's okay to throw garbage out the window, then yes, we get lots of garbage. So it's just logic to understand consequences, to add up where the dominoes are going to flip to, what the result of your actions are going to be. I light the match and I put it to the paper, I should have the expectation it's going to burn. And if I think I have some magic that's going to prevent that from happening, I have to explain what it is, like, oh, the paper's wet or some other thing. So it's really just about an argument about certain direct questions and whether answers are correct or not. And you're saying that you have sources like Ken Wheeler who gets the right answers, that provides right answers with some reliability. My contention to you is, no, depending on the question, his answer is going to suck really bad, or he has a chance. So if you're going to ask him a camera question, I'll say, okay, good source. But if you're going to ask him a physics question, bad source, because his underlying understanding is so wrong, and so it doesn't contain any facts, correct ones. So there's even a word like even the fact that you would have to say correct facts, because facts have been so tainted. The word fact has been so tainted by people claiming that they have a fact when it's not really a fact, and it's so pervasive. I noticed that I was listening to an audio book of some guy from the 1800s talking about electricity, and they're so confident about the existence of the ether. They don't have any evidence that it exists. They just like it as a way of explaining things. It just provides some sort of generic functionality that they can rely on, and they can just, wherever they don't understand something, they can just say the ether did it, and it just provides a nice little gimmick. But maybe if that guy was alive now, 100 years later, he might say, oh, I get that's just pushing, that's, I'm just using it as a fallback position, because I didn't understand, it's that kind of thing. I think these people were smart, and they made a few little mistakes, But if they lived today, they wouldn't make those same mistakes, I guess would be my argument. Is that if you took their knowledge base, they'd be able to see where, oh yeah, I drew a conclusion way too soon, and it was too convenient, and I fell for it, and I shouldn't have. Something like that. But I'm just saying, this whole having a competition, the competition shouldn't be about authority, like my reputation, my integrity, my something else. It really has to be about each subject, and about whether or not that subject, first you might be able to say that the source is reliable, or more importantly, you understand the reasoning they're using to defend their answer to the question. They're not just giving you an answer, but they're giving you an explanation for why they believe that answer is correct. And that's probably the more important part. So when somebody says these silly words, the counter space did it, or they have to explain what they're talking about. They have to be able to explain why they believe that. And it has to be a better reason than, well, because Aristotle said so, or Plato said so, or some other kind of bullshit. That's not a good enough reason. You have to explain logically why it's a good answer to the question. Something like that. So anyway, but again, this is another thing where people just use words like smart and intelligence, and it's kind of a deceptive concept, because knowing a lot of stuff but having a poor reliability in terms of organizing that stuff into conclusions, just means that you might as well not know anything. If you can't depend on it, there's no point in it, kind of thing. You don't want necessarily fast, you want good, that kind of thing. You want it, it's more complicated than just saying how much trivia have you stored in your brain, how many things have you memorized. Being smart is more than that, I would argue. So anyway, are intelligent. Then you get into words like knowledgeable, and even wisdom. So I mean, obviously, so this is you would argue that what you're looking for is wisdom, because that has a higher standard of reliability. But again, they're just words, and you really have to do the thinking for yourself. If all you're going to do is say, I don't really want to understand the subject, and I'm just going to pick a leader, then you're just a sheeple. You're not. I mean, nobody can know all this stuff. That's the problem. So we all have to go through our life trusting people. You go to a doctor, you have to sort of trust that he's, kind of understands all of this crapola that he's supposed to understand. About how system works and all that kind of crap, and what'll fuck it up and what'll make it better. Because you can't understand it all. You can't be an expert at everything. But I guess there's a certain ways you could test your doctor to see, see how reliable he is. See if the horse shit he gives you as an explanation makes sense or not. See if you can find those organs that he's talking about in the body, and see if you can find any information that says that makes sense. Because that brings up a whole bunch of more crap, where, I was also doing some more Tesla research and his autobiography and stuff, and he tells stories about how he had all these horrific diseases and conditions that doctors completely gave up on every time, and he miraculously cured. And, it's like, oh, so he had every shitty doctor that ever existed on Earth or something, They were that unreliable, especially with things like cholera. I mean, they knew what cholera was, and there's certain treatment, and that's all you had, and blah blah blah. So it's not really a doctor's fault. But anyway, Anyway, all right. So I'll move on. Just pointing out how the subject of what's in. Because this one guy who was writing about electricity, very thoughtful scientist, very thoughtful in how he's going through the procedure of explaining the experiments he's done and the conclusions, and it's a lot of it had to do with like Morse code days and all that kind of stuff. Very interesting, sort of. But clearly, somebody who's well disciplined in the scientific method, and yet his conversation it was like he didn't even have to defend the idea of ether. It was like it was just a fact. And yet, if you pressed him to explain, well, how does this thing more complex than the elements that are interacting with it? How does it form? What's the mechanism? What are you talking about? Where is And clearly the wave theory, waves that move in straight lines, it just doesn't make any sense. But anyway, we won't get into that. I mean, they're obviously, in those days, they weren't thinking about sending single photons into experiments. They were thinking photon meant some kind of bunch of photons or a wave of photons, or however they were thinking about what a photon was, but they certainly weren't thinking about it as, discrete quanta. So anyway, so here's a guy ragging on Ken Wheeler, which is okay, but you should rag on him for what he needs to be ragged on for, which is just regurgitating a bunch of ancient bibble babble. Ken Wheeler does not know anything about science nor photography. Well, he obviously knows something about photography, some of the mechanics. I mean, I would say that he has his own biases and prejudices regarding certain bits of technology, but whatever. He's just a habitual liar. He lies a lot, I would argue. Yes, he's deceptive. I don't know what polite word you can use for being dishonest about it, frankly. I mean, he's not honestly explaining what he knows about ferrocells, clearly, I'd argue. So he's clearly not pointing out how, well, I can tell you that it's bending light, but I know that, the little things are lining up this way. They're not lining up in swirly lines. Just the fact. He proposes himself a genius, but refuses to comment on the glaring inconsistencies in his pseudo-knowledge. Well, he is a coward, clearly, who claims many victories in battle, but there's no demonstration that he's ever fought a fair fight in his life and won. So, yes, he's a glaringly disingenuous in his claims of triumph. You just get insulted, or you just get nothing. You get him running away. So, insulted by a moron. It would be a moronic insult. That's all he has, is moronic. I mean, when I challenged him early on in a nice, polite way, like we should have a conversation, all he did was mock my appearance, as if that makes any sense from his glass house. I mean, he's got these mockable rituals and bullshit tattooed all over him. Big holes in his ears. I mean, just kind of cliche, I'm being different bullshit. And then he mocks somebody who's different. I mean, it's just hilarious. Because he doesn't have a real weapon. Anyway. Alright, 1820 is where it clicked for me. Well, I guess that's sort of an interesting fact. I think that was, what the hell was 1820? Yeah, I'll remember in the video. Well, anyway. Good. That's what I would say to that. 1257, I don't know what that means, but fine. I guess it was a funny moment. Alright, Rob C. The ability to graduate college does not make one intelligent or intellectually honest. Right. But it's better than not graduating from college. So I'm just saying, if all things are the same with an individual, better to have gained knowledge than not to have. So, your brain is going to work better if you're absorbing information better than if you're just bouncing a basketball somewhere. So, just a fact. Excellent video. See, but this is the funny part, right? Excellent video, but a bit over my head. see. So you don't really know whether it was an excellent video. I mean, not that I don't appreciate the statement, but it's, you're not qualified to say. So you're admitting a bit over my head. So you're kind of admitting, yeah, I really don't understand what you're saying, but I like the way you're saying it. I mean, that's okay, but it's not very logical. But I'm trying my best to understand. Well, that's all you can do. I'm trying my best to explain it without you having to go to college. To explain that these are the basic things that happen. All of physics is really just stuff, a conversation about something called a force and something called matter, and the interaction between this stuff. And the fact that I can give you the simple example of the ping pong paddles and the ping pong ball. And I can say to you, this is the weirdness of the universe right there. Because all I have to do to make more energy is move these two things closer to each other, and these ping pong balls have more energy. Just because they're making more impacts. So energy really isn't so much just the fact that something's moving, the ping pong ball is moving. It's the fact that it's moving in an environment, okay, where it has interactions. And the interactions are the expression of the energy. It doesn't really have any until you make it interact with something. And the more interactions it has, the more energy the system will have. So I can give you this simple explanation that the universe is really something about this idea of pressure and moving things closer to each other. As much as the universe says, oh yeah, it looks like it wants to do that, fact is that makes more energy. So the closer you move things together, the more energy you're creating, quote unquote, the idea of energy. And energy is really something you only see, okay, when stuff you can see is moving. So the stuff we don't see, the forces, the radio waves, and all the other crap flying through us right now, we don't see any of that crap. That's the real energy. But how it gets expressed into something we can sense or know exists is when it moves the little electrons and protons, the matter bits. And the catch is, the closer the matter is, the more energy it has in it. So you can understand that, well, as the universe moves pieces of matter closer together, in spite of what it appears like, that's making more energy. It's not using more energy, so to speak. And that explains why this matter stuff has energy innately. Just by existing, it has to have energy because it's created closeness, and closeness increases energy. Alright, anyway. Can increase. Yeah, so I threw a trick word in there right at the end. Can, yes, it's possible. Anyway. It's difficult. But I'm just saying these are different ways you can start. You can start with understanding something in a certain way. And that's what I'd argue, that the very fact that I'm here at this moment in time making these arguments is almost inevitable from the time when I was like 7 years old and I started hearing what they were saying reality was. And I never could conceive of this thing called an ether or a field or a wave, even in physics, to make any sense. And it always, for me, had to be little bits. I mean, that's how, as soon as I heard the word photon, I said, photon, yeah, little thing moving at the speed of light. It couldn't have been anything. I couldn't imagine it any other way. It's the only logical way you understand something going from point A to point B as a clump of energy. It's a clump of energy. It's a clump. What do you mean? It's a wave. A wave of what? A wave in what? A wave? What are you talking about? Just couldn't make any sense out of that. It just never. It just, every time somebody would say the word wave or field, those words would go right through my brain. Field of what? Field of what? I mean, it has to be made out of soldiers or something. So I'm just saying it's sort of inevitable that I'm here making this argument because it just won't make any, I can't fit it into any of the other facts I know in the universe, this idea that, oh, ether exists. Ether doesn't make evolution better to understand. It doesn't make car headlights better to understand. It doesn't make anything I can conceive of, doesn't make it more understandable by imagining, oh, it's really vibrations and a bunch of dominoes or something that somehow can go in any direction in a straight line. I mean, it just doesn't make any sense. So anyway. Gary, do you think increased redshift of more distant objects could be the result of interactions between photons and incident matter? So again, this was apparently he didn't watch the other why can't this be true thing in the 15 videos I had to make to get to the wrong answer, to make a mess of the subject, actually. So yes, I do believe it, and I still do believe that's what happens. I just have to come up with a better physics explanation of how it happens. All right, matter that moves into the beam of photons. Yes, and I'd say transparent matter would be the more important word here. I think it would have to be transparent, obviously, throughout the whole beam. Yes, well, the whole beam isn't, in my opinion, very much. When you're getting to photons, the ray length is pretty small. It only has, 10 quanta in it. In other words, creating a more diffuse, lower frequency beam of light photons the further the light has to travel. Yes, it's lower frequency is a good word, but then you start to talk about speed, which is a little bit more complicated. So, can reword if needed. I'm really starting to get the purpose of trying to say the same thing in different ways. Yes, it's sort of necessary because words are tricky. This rests on the idea that light slows down. See, this is such a messy phrase when moving through matter, because obviously you can be slowed down by moving the same speed and just moving more distance between point A and point B. If I make you run a different path in a straight line, it's going to seem like you were really slow because you're going to get to the finish line really late. But you were obviously running the same speed as the other guy who did the straight line, but you're going to come in way behind him. So you didn't slow down. That's just wrong to say. And I would argue that logically we can sort of understand that the force, as manifested as a photon, goes through transitions as it moves through a transparent medium. It doesn't just travel as a photon through the medium. And so it interacts with the electrons, and when the electrons are moving, they're moving much slower than the speed of light. And the electron is really transferring the pressure from one atom to another atom in the case of electricity. And in the case of light, it seems clear that the interaction is more, although between atoms, it's between the electrons in a pattern and certain kind of geometry of the atoms. And it's just creating a circumstance where that geometry isn't a straight line. It has to go through the part of the interaction happens through movement inside the atom that slows the progress because the electrons are moving slower than the force that's pushing them. But it's all got to be translated. See, electricity goes through. So if you thought of the stuff as being the same stuff, like electricity and photons are the same thing, they're forces. So if you had them in some free form, they're moving the same speed and they're fine. Now they have to go through a conductor. Both of them light doesn't need a transmission medium. But clearly, what do I want to say about that? Fields can't have any meaning until they interact with matter. So electricity is atoms sharing pressure. So the pressure interaction just happens between the atoms. So you could say the electrons are here and they're just interacting between this electron and this electron, but that interaction just moves the atoms. So that's sort of the difference, is the atoms move the pressure. Yeah, even that's not quite right. See, so that's the subtlety of this. You really have to get to the essence of it. But I'm saying for the purpose of visualization, you could say these are all the same things. I mean, electricity is just photons moving through a conductor, but they move different than they move when they're in the form of photons like light, visible photons. Yeah, so I'm just saying that you could understand that it's all the same stuff, and it's just how it moves through something is changing how fast it can move through it. Yeah, it's all just paths. This gets into heat, because heat is, we say the word heat, but heat is again just this little stuff that's pushing the atoms and making them move more. So the more of this little stuff, this force you have in a mixture of something, the more it's going to keep banging into atoms, and the more atoms it's banging into, that it's moving them each time it bangs into them, the more the atoms will get likely to be banging into each other and interacting with this force, and the ping pong paddles just keep getting closer and further apart and closer and further apart, because there's stuff making that. The more stuff, the more ping pong balls, the more active the system's going to be. All right. Alec Griffith. Did I finish this? Yeah, I did. Let's see. This rests on the idea that light slows down, when moving through matter. Again, I don't think the light, the force, actually slows down. It just takes a longer path. See, again, you could say it slows down because you could say, yes, but it's not light when it's in the form of a moving electron. So when it moves an electron, the force isn't really in the same form, but there's a huge correlation, as we understand, between the momentum of an electron, how fast it's moving, and what frequency of interaction hit it. Those two things are just right next to each other as correlations. All right. Let's see. To me, it kind of looks like Hubble has a slight optical atistimism. Yeah. Well, I just know, I don't have any deep knowledge of all the problems Hubble had, but obviously from the very beginning they had a problem because the mirror wasn't the right shape, and they made a mistake, and so they had to correct for that. And so then part of correcting for that, I think, was just a bunch of software corrections. They could never fix the problem of the wrong shape, but if they put new instruments on the Hubble, the new instruments would compensate for the defect in the mirror. So they couldn't fix it from Earth, but they could fix it by installing better crap on the telescope, better hardware. Combine that with some motion blur, asteroids, photo bombing, and you got some weird shit going on. Well, I think the weird shit also has to be recognized is that they don't really have a great way to tell distances. This whole candle power thing and understanding what's close and what's far away. They don't really, it doesn't just overtly say to you, I'm an object 15 billion light years away, or I'm an object 5 billion light years away. So a lot of this gets complicated in terms of making judgments about what is in the foreground and what's in the background. That in itself is a kind of a deep science. Hubble also takes multiple exposures and combines them. Yes, this is the tricky part, is that a lot of this is software interpolated, blah, blah, blah. So any sort of swirl in optics or movement by Hubble will get exaggerated over time and cause weird and strange shapes. Yeah, well, they're mixing images from different wavelengths also of the light. So, lots of things to say, yes, something could have gone a little bit wrong. I'm still arguing that the images are correct, let's say, and all you need to do is explain the fact that there's an object there. It's not an image defect. I mean, it's not an illusion. That there's just a real object, So, and it's just not that big of a deal to say, oh yeah, the universe has some things that are the byproduct of some sort of catastrophic explosive event. Hubble will get exaggerated over time and cause weird and strange shapes. Okay, Hubble is moving very, very fast as it orbits around the Earth. So yeah, imagine doing several long exposures of the galaxy here on Earth from a moving boat with a 30-year-old lens, then bending them together, and you're going to get some weird things happening. Yeah, I agree that it could just be that this is a defect, because we don't see we don't get to see the raw images. We don't see like, well, this is what we got in infrared, and this is what we got in this ultraviolet, and this is what we got here, and this is what we combined, and this is how it changed. So we don't get to see the evolution of the photograph from the raw data, the raw image, the raw pixels, to something they've synthesized out of them. And that's a huge flaw in all of this science, is the fact that there's no publicly accessible data, and they really shouldn't be allowed to claim anything if they're not going to make their data and they shouldn't be called scientists even. Fuck that shit. It's just, especially when the government paid for this crap, it should be public. Every bit of it should be public and easily accessed. And they've made it really hard to access. You can't even know what you're looking at, because they give these things stupid names. You can't even star NW480 blah 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 blah. And you should be able to just do a simple search. I want to see every image you have of this galaxy. I want to see every image you got. You can't do any of that stuff. It sucks. The data, the background data is just garbage, and it should all be public, and it's not, and that's bullshit. This is also why there's no consistency in the Hubble images. You probably get different effects happening depending on where the Hubble is pointing, how many exposures were taken, how long they were in the Hubble is in orbit in relation to that shooting. Yeah, well, I'm just saying that obviously we're always changing positions in space. I mean, actually, the sun is moving with the Earth orbiting it, and it's zooming in a direction. So obviously, all the time, if we're going to take a picture a year later, we're not taking it from the same exact spot in space. And the whole point of these lensing images is that it's very, very specific about what you're going to see at different locations, and you won't see the same thing from a different location. If I move my eye pupil just a little bit over, I'm going to see different pixels will be lighting up different things on my retina, and it's just a different image, and there's no getting around that. And lensing is very specific to a very specific point that it focuses to, and you just move a little bit, right to left or up and down, and you're going to break even forward and back. The focal length is very specific also. So that's the whole point, is that how can you can't get the same image from two locations, and so we should see these things not exist and exist. They should be there, and then the next picture they shouldn't be there. And that's a fact. But anyway, a pretty secure fact, I think. I see secure fact. I think it's quite reasonable to be suspicious of all of this stuff, because again, we're not given any of this information. How many exposures were taken? Okay, we did all that. Sometimes Hubble will shoot one spot of the universe over a long period with exposure times equaling 10 days. Yeah, well, that's, then it's really dependent on a lot of computer software to sit there and create the image. And, some of it you can kind of see that's what they've done, because the stars all get round. Probably the image they have isn't round, it's all pixelated, and they're making them round, They're doing a lot of stuff because they know what it really is, so they're saying we can clean this up with software and make it look like it's supposed to look. And that's the dangerous part, is how much of it is synthetic based on software saying this is what suns are supposed to look like, and how much of it is a real image. So it does this by stacking hundreds of thousands of shooter exposures taken to minimize the motion blur, which, yeah, the damn thing is constantly moving. What we end up with seeing is not gravitational lensing, but circular aberration from the Hubble telescope as it shoots its long exposure sequence over weeks and months while it's moving in a circle over through the Earth moving. So, yeah, okay, we get it. We get that point. I get it. Also, I want to point out there are two images of quasar SDSS, yeah, fuck these stupid names, that are a year apart. One looks like this. So I couldn't, you can't really see much difference in my opinion, but, I mean, it looks like crap. And, I mean, I would argue that you can't even make any lensing sense, because the blur is in straight lines, and that you can't make any sense out of straight lines when you're talking about gravitational lensing. It's the obligation for strong gravity to get circular is so dominant that you could never explain a straight line lensing artifact. Just can't explain that. Too crazy. And then I guess he's got another one here. Then a year later, looks like the nonsense looks like this. Yes, well, it does look like, a bunch of junk. But clearly, all these arcs all can't be the same source of gravity. Can't lens from all these different positions. I mean, this arc isn't even centered on this bright spot here, obviously. This one would be like a circle going here. This one would be a circle going here. They're not even consistent. So this has a little bit of consistency, but if you really drew a line and said, okay, there's strong gravity here, it's not a circle again, it's an obloid or something. It doesn't make any sense. Can't be. Just can't. So obviously this flare or gas or whatever this extra stuff is it's either a real thing that they're taking a picture of, a real artifact of the galaxy, or it's a manifestation of their computer software trying to make sense of the pixels it's given. But the evidence is way too weak to draw any conclusions, except the conclusion I think that's logical is there's no reason to presume lensing. Alright, rotate it counterclockwise 90 degrees for it to line up. I don't think I want to do that, but okay. The second image is much higher resolution, which means they probably did their multiple exposure deep look technique. Yeah, they applied better software, software that cleaned it up, that made it look more like what they expected to look like. So they took a picture of some fuzzy Sasquatch, and their software made it look like a panda bear. Since so many NASA's images are done through computer-generated compositions, I wonder if they are using distance data taken from Redshift to attempt to compensate for the parallax that would happen from the movement of the telescope through the sequence of exposures. Yeah, who knows what they're... Again, this, like I said, it should be sort of public information. You should be able to just click on a website that explains, well, this is what we do to our photos. Here's a typical example. We get this as data, and then we put it through process A, and it does this to try to clean up the image, and then the next process does this to clean up the and they should explain all that crap, but they don't. So even if you want to know, you can't know. And clearly everybody's just using it as if this is a pristine source of information, and that there's no other way we can explain any of this except to create a theory that doesn't make any sense. So now they're just using dark matter to say, well, the reason why it's not spherical is because there's magical dark matter there and there's no dark matter over there, some kind of bullshit like that. So it's just junk as science. It's not science. It's religious reputation, or whatever that is. It's just attempting to defend their religion. So glad someone is addressing this. Well done. They seem to be redefining the word science. Well, I don't know what video that is. It's a half a day video, so, but whatever. The word science. See, this is another thing that the way I look at it is that science it's more like an ambition, to understand. So that's what science is, to understand. And it doesn't matter whether you're trying to understand what it is to be a human being sitting on this stupid earth, or whether you're trying to understand why gravity makes this happen. It's all science. So philosophy is science. You're applying the same methods. You're using logic. And so this is where it gets tricky, right? Because some stuff is just so nice and physical. It's right in front of you, and so you can sort of make arguments. But the stuff that's really making this happen is invisible. So it's really tiny, and it's really hard to see. And so you have to keep deducing it from all the evidence. So it's like, I've compared it to a detective. You're just showing up at the scene of the crime, and you're trying to come up with some correct Rube Goldberg explanation. So you have chicken, flattened by 10-ton weight at one end. and you're saying what sequence of events led to the 10-ton weight falling on the chicken. And that's all you're trying to do. And so you have little pieces of evidence of what the Rube Goldberg machine is doing, and you're just trying to put the pieces together. So I could give the connected dot analogy. It's a bunch of dots, and you're trying to connect them together, and you just don't have enough dots to tell the difference between platypus and swan. And that's the problem. So, the evidence is marginal. And you're just trying to point out how, well, this theory won't work because we know this dot is good, and we know this dot is good, and we know this dot is good, and you can't do swan with those 3 dots. I would argue that's sort of what the argument's about. What facts indicate that something's not going to work? And so Feynman sort of made the argument that he can't really buy this wave theory because he knows the photon arrives in a clump. Okay, he knows that waves don't do that, as he said. Waves don't do straight lines. That's not what a wave does. And I think he just knew it's kind of silly to say, that it physically actually goes everywhere. It can't physically do all that. So there just must be something built into it that is imitating that behavior, not actually doing that behavior. But anyway. So what else? And again, it's not even imitating that behavior. It's imitating a lot of different explanations you can have for the same end result. So again, it's the idea that if you have enough missing pieces between, the duck under the 10-ton weight and the starting point, which is whatever, you don't even need a starting point. You're just trying to figure out how the 10-ton weight got on the duck. And if you got too little information, there's just lots of ways you can explain. The 10-ton weight was, walking to the store, and it slipped on a banana peel, and, it created an energy displacement, and flipped it in the air, and it landed on the, you come up with any kind of crap. So you need some dots to be able to start to say what it can't be. And so those are the 2 things I'm doing. I'm showing you why it can be this real simple explanation, simple force matter dynamic, and why that does actually work. And I'm giving you the argument that this is why their thing doesn't work. First, there's no unification, the completely incompatible mechanisms for giving birth to 10-ton weights. They have one theory that says 10-ton weights are made by, process A, and then they have another theory that says, no, they're made by process B. They can't even figure out what their elemental mechanism is. The bent space does one thing, and virtual photon does another thing. Well, which one of those 2 things is true? Oh, wait a minute, they're both stupid. Neither one of them are the right answer. Virtual photon, well, yeah, no, that's just stupid on its face, right? And then bending nothing, well, that's kind of just plain. Why would anybody think you can do that? Let's bend nothing and change everything in the universe by bending nothing. So, that doesn't make any sense. It's stupid. Alright, so I guess I'll take a pause here and think about. See this. There was a Richie comment here on photons, and he just says a lot of crap, so I probably should comment on that. So anyway, I'll pause and decide whether I have more to say or whether I'll just call it a day, or morning or something. Alright, should be back. Alright, so I'll read some of this, just some of it. There's no point in reading all of it. So the first time, I've said this before to the Robert Ritchie guy, is that the purpose of my channel is not to debunk 3rd or 4th or 5th theories. My objective is to point out how conventional physics is wrong, and it needs to be replaced with a more coherent, simpler, more reasonable model. And I would argue that I've reduced the model to such fundamental and elemental elements. You can't get a simpler diagram of what a photon is than the diagram I'm drawing. Can't make frequency, little bits at a distance You can't you can't manifest frequency any simpler than that. There's no simpler explanation for what a photon is. So I have the simplest explanation, and it does everything it needs to do, as I'm explaining. So I don't need another theory. I'm not looking for one. I'm here to defend mine and to tear down theirs. I'm not here to point out to you that you're just providing me another unevidenced pile of crap. Alright, so unless you can cite some evidence that you've especially accounted for in some way that nobody else has, you're not offering me anything that's compelling. Alright. Forget the ropes. No, I'm gonna argue with people who make claims. And get back to the fundamental view I have of photons. I don't know what that even means. I'm always talking about my fundamental view, and my fundamental view has nothing to do with your view. Clearly. And you're pretending they have something to do with each other. They don't. Individual quanta tracing a ray between 2 points. Yes, so now we're done. That's it. With a wavelength. Yes, we're done. So why do I need to listen to any of this other crap you're saying it is doing when you're saying it's not that? You're not describing a ray. For reference, the ray is traveling a path and the projected path of the photon. Duh. It's moving in a straight line. Also, last time you misquoted me. I don't think I did, because your next paragraph's going to demonstrate. How could I possibly misquote you? Because it's more just made up crap. Whether by misrepresenting or mistake what's said, let me clarify the point of my argument. Okay. A photon has properties. Well, as I've pointed out, no, it really doesn't have properties and like a whole bunch of them. No, it has simple properties in the sense it's a clump, a thing with momentum, and it's moving in a straight line direction at a speed that is constant. And every single one of them is doing the same thing. And the only time a photon becomes what we call them is when there's a bunch of those in a row, in an array. But the single quanta has only the property of moving the speed of light in a straight line in a direction. That's only one property, essentially. So the quanta themselves have only one property. Light speed travel, the speed of force travel in a straight line. That's all they have as individuals, as a property. And a certain amount of mass. Capacity to transfer their momentum. Alright, to have their momentum absorbed, better put probably. But anyway, the photon has properties that determines the outcome of the photon-matter interaction. So I'm arguing exactly the opposite, clearly. I'm pointing out that the matter is what changes, has very different configurations, and the same thing goes in and some different thing happens depending on the properties of the matter. The photons can't be changed. The ultraviolet light is ultraviolet light, and the reason why you get a different reaction is because the chemical it hit is different. The atomic structure is different. The photon has two frequency properties. Says you. Based on what? Where do you have a single shred of evidence that there's any other frequency involved in a photon? Oh, that's right. There's no experiment that says so. So until you cite one, this is just made up crap. And the first you are very familiar with, and that is related to the energy of the photon. Well, again, we're talking about photons. So we're using the word photon. When I'm talking about the quanta that make up the photon, you're talking about whatever the photon is. So again, this word photon doesn't mean anything. In my opinion, the energy of the photon has to do with how quickly you're sending the energy, right? So I can take the same amount of gasoline and have two cars. And one car I just go 10 miles an hour and I go really far. The other car I go 70 miles an hour and I don't go very far. But clearly, if I put a brick wall in front of them, okay, I'm going to realize a lot more energy out of the one that was going 70 miles an hour than the one going 10 miles an hour. And same fuel, right, but a different outcome. Just dependent on this speed or frequency thing. How quickly did I send the energy, in what amount of time? And so clearly time has time is distance. Distance has a relevancy to pressure and the manifestation of energy. This is what we call the wavelength. Oh, fuck you. The photon, the photon and does not manifest. He puts that in capital, and does not manifest. The photon doesn't manifest, frankly. The wavelength certainly can't be seen by anything until the photon does hit something. So we can't see a photon. We don't see laser beams, right? We see the photons being reflected off of a piece of crap. We see the photons that don't go from point A to point B when we see a laser beam. We're not seeing the photons that made it. So photons don't manifest any property until they hit something. That doesn't mean they don't have the property. They're a row of energy moving in a straight line. Okay, the soldiers are heading for the destination. Yes, they don't do anything until they get there to shoot the Nazi or whatever. Obviously, it doesn't manifest until it gets to something that it can manifest. It just does not manifest until the photon interacts with matter. So I would argue no. It has a frequency when it left the building. The soldiers are in alignment. They're 10 feet from each other. Period. Whatever it is, it's doing what it's doing. It's a photon throughout its whole trip, and it doesn't change until the matter interprets it. That is to say, the photon does not oscillate while it travels at the wavelength frequency. Well, again, who are you arguing to? I'm obviously arguing the photons aren't doing any of this waving crap. There's no such fucking thing as a wave. A wave is an emergent property. Photons are traveling through empty space. They're not traveling through an ether. They're not jello. They're not bubbles in jello. They're not lumps in jello. They're not any of this bullshit. So again, why are you preaching this crap to me? A good way to visualize this, I'm sure it's not, is as the photon is a tiny magnet flying through space. Why would I visualize a photon as a magnet? It has no polar attributes at all. It doesn't do anything electrical or magnetic ever. Why would I think of it as a spinning magnet? There's no point. The second frequency associated with photon is the angular frequency of the photon, whereby the photon, while traveling through space, can spin like a baseball. Says you. So it's a magnet spinning like a baseball. That would mean it's making all kinds of polar interactions. That means force is flying off of the photon. So the thing moving the speed of light that I would call a force, you're saying is making force. No, it isn't. The velocity and wavelength do not change, but an additional property of photon rotation can be added. Whatever that. So before you said it has the two properties, then you say it doesn't. I guess clearly if it's not spinning, that's a kind of spin, zero spin. So what? Obviously I have no reason to believe photons spin. You're not providing any logic why I need to give photons all these properties. Why do I need to do that? What do photons do that you think needs the photon to have to explain it? When clearly, in my opinion, obviously everything can be explained by just blaming it on the matter it's interacting with. It should be noted that the photon rotation is not an essential component of the photon. Well, says you there again. So you're creating fucking faculties it has that isn't essential. Then why do you believe it exists? It must be essential to some kind of outcome. It must create an outcome of some kind. Why are you believing in it if it didn't create an outcome? And all outcomes are essential. There's no such thing as an unessential outcome. The larger the wavelength, the lower the energy of the photon. So again, more, I would argue, abuse of words in a sense. Okay, because again, that we're just talking about a time component. We're talking about the fact that, yeah, if I spin a record, if I put a ball bearing, or I just put a piece of something on a record, an old 45 or whatever, and I spin it with my finger. Well, if I spin it slowly, it stays on. I spin it fast enough, it flies off. It's just a tension argument. I can use all these kinds of examples of how you have to hit things at a certain frequency or have to hit things with a certain speed for certain events to happen. Clearly, wavelength of photons, electrons are very sensitive to the wavelength of a photon. They'll react very differently at some wavelengths than they'll act at other wavelengths, which means they'll fly off or they won't fly off. That's all there is to it. The photon has nothing to do with it. What will decide whether it flies off or not is how much weight or friction it has, or how much tension it's in. All right. The larger the wavelength, lower the energy of the photon. And that also equates to the size of the photon field. So whatever the fuck that is. Again, we're talking about what a single photon is. We're not talking about a field of photons. We're not talking about the light bulb. We're talking about an individual bit of quanta in a stream, a ray coming off the light bulb. So we're eliminating all the other ones, and we just have one photon that gets through the filter. What is that one photon fucking do? We're not talking about fields of anything. No more crap. Alright, when the magnetic field of the photon, it doesn't have a magnetic field, of the correct side interacts with a metallic object, an electrical current is induced in that metal object. Says you. So again, with no mechanics, no explanation of how it does any of that crap. Just this magical field, and the electron reacts to the magical field. I'm obviously arguing a completely different theory. I'm arguing the photon actually hits the fucking electron. The electron absorbs the momentum in that it makes a momentum exchange. It takes on motion in one direction. It gives back motion in the opposite direction. It does Newton's thing. It does an equal but opposite reaction thing. Okay, so it takes this and it gives back that to take this, which means the electron now has motion in a direction. And it's not new energy, because it gave back energy to the universe. So it's just changed its personal balance. So instead of having a balance that says I go this way, it has a balance that says go that way. Or it has a balance that says I'm going this way a little bit, and now I've taken on another piece, and now I'm going this way twice as much. But that's all that's going to happen. Alright, induced in the middle. The higher the energy photon fields, the higher energy photon field. So again, this little simplest thing in the universe, moving the speed of light, tiny quanta of energy, and now we're converting it into something that has a whole field around it of some kind. No evidence of any of that. Are increasingly smaller, and the energy is inversely proportional to the size of the photon field. Whatever the fuck any of that means. So it has more field if it's a higher frequency, and less field if it's a lower frequency. So if there's a greater distance between the quanta, somehow that means it has a bigger field or a lesser field. Fuck you. You just made all that crap up. Counterintuitive as it may be, this model so far is provable by observation of the world around us. Says you. I don't see any proof of your field. I don't see any proof that the fucking photon is a magnet. I don't see any proof that it's spinning. I don't see any evidence for any of that crap. So what we have is standard photon that is the same size as all other photons. So you're making them standard when they're not standard. Obviously the frequency is the unstandard thing, but that's because they're in groups. But as individual soldiers, they're identical. That would be my argument. That would be my explanation. Your explanation is obviously something else, because you're giving the photon. I don't know whether you're saying the individual photons are spinning magnets. What the hell are you talking about? It is just the photon field structure. There's a photon field structure. Where do I get that from? Where do I see evidence of any field structure? That varies in size, and that is determined by the amount of energy that produced the photon. So just more crap. Whatever energy produced the photon carries it. It can't hide what it is. So frankly, the energy, if it has extra energy, it should be decipherable by looking at it. From my studies, whatever that means, I have found that you can alter the energy of a photon by simply adding or subtracting energy from that photon. So again, you can't change the quanta. So now you're saying photon is a group of quanta, and you're saying you can change the energy by what? Smashing them closer together. Well, of course, that's more stuff in a confined distance. So more stuff in confined space obviously does mean more energy, yes. But not in any kind of, it just has to do with the distance argument. Proximity is power, or however you want to put it. Addressing the other topics in your video, well, you certainly didn't defend the one you spent the most time on. Anti-gravity. Theoretical evidence points to theoretical evidence. What is that? What's theoretical evidence? Points to the existence of gravitons. No, all of conventional physics believes space is bent, okay? So that's not gravitons. So I don't know where you get the evidence that they believe in anything called a graviton. And if they did believe in it, they don't think it's doing push, and that is, it's not like asteroids hitting us and moving things in towards each other. So they're not thinking of it in terms of mock gravity gravitons. They're thinking the gravitons somehow give things gravity. They don't think of the gravitons as actually being a physical energetic force. They think of gravitons as they think of Higgs bosons, as some kind of things. You eat a Higgs boson, now you have gravity. Now you're real. Where you weren't real before you took your Higgs boson vitamin pill. And that is my area of experimental research at the present time. Oh, so you have a accelerator somewhere in your backyard. And when I get a graviton controller working, you will be the first to know. Well, I probably won't be, but regardless, photons are controlled gravity. Magnetism is controlled gravity. I mean, you've taken gravity, a force, and you've segregated it into poles, plus and minus, north and south. Proton-electron force. So you're controlling the gravity in the sense that now you've segregated it, you've made it a more powerful force. Photons are merely a segment of that gravity, the electron force, and you're controlling that, okay, by segregating it and changing its direction, where it was going in the universe. By changing where it's going, you're going to change its impact. Clearly. It's not going to hit one thing it was going to hit, and it's going to hit something else that it wasn't going to hit. Alright, so, but you can't undo the energy in the universe. So pressure is real, and if you want to do an anti-pressure, right? If I argued I'm going to make an anti-pressure device, I kind of understand that I have to make something as powerful as the pressure. It's like an anti-bullet device or something, right? I have to make something as solid as the bullet that has enough energy to push the bullet back, to stop it, to slow it down, to prevent it from hitting me. So I can't do it with some simple thing. I have to hit it with an equal and opposite amount of energy. So if I want to stop the energy of gravity, I have to apply energy to do it. Now the trick is I can do it with magnetism, because magnetism gives me this much powerful force by segregating the force, and so I can use a magnet to levitate. Alright. Faster than light speed theory. Yeah, right. I will leave that for the science fiction movies. Well, everything you just talked about I would leave for the science fiction nonsense. Spinning magnet photons. We as a so-called sentient species have not yet developed far enough to understand all the intricacies of the universe. Well, yeah, that's a given fact. Okay, yeah, it's really small stuff. It's really hard to see. We've done pretty well, I would argue, in gleaning lots and lots of facts, and I would argue that we have enough dots on the page to draw a rational picture. The problem is people don't want to draw a rational picture, because the rational picture basically says, oh, we're just robots in a deterministic universe. And it's really quite pitiful. The whole thing is quite sad and tragic. And they want to draw that picture. The thing is ugly as fuck. Okay, the universe is an ugly truth. And it basically says we're annihilated in the end. There won't be a shred, not even a trinket. There won't even be a little charm left over or something. Nothing. All the gravestones will be particularized. All the graves. There won't be a single shred of evidence that this bullshit ever even happened. And that's all the truth they don't want, so they have to wave the whole thing up and make it godlike so they can make it all mean something. Some kind of bullshit like that. And certainly they want to travel to other galaxies and they want to do all this other crap, so they have to create loopholes that make that possible, and wormholes and all kinds of bullshit, to keep their fantasies alive. But if you look at it as what it is, it's just this mechanical process. It is a fucking clock. It's just clockwork. It's a Rube Goldberg machine that has really simple pieces. It's just got two kinds of force and two kinds of matter. That's all it is. And that gives you all you need to create traps. It's a road paving machine, and the machine has a logic built into it that allows it to take right turns, and it can take 4 right turns and end up stuck in a fucking circle. That's all it is. And so you're looking at a universe that's just a bunch of traps and just a bunch of stuff caught in circles. Circular paths, let's call them. circle-like paths, paths that have no, that don't go anywhere. They end up back at the same place later. Oh, I'm back at the same place later. I'm back at this. And that's all the universe is really doing. That's the only mechanism. Is taking stuff that was moving in a straight line and making a straight line path that just ends up being circular and ends up at the same damn place time after time after time. And it can be released in the future that way or that way or that way. It can get out in all kinds of directions. And when in one direction, it can get out in all kinds of directions. That's all the universe is doing. Alright, so let's see what the Moog T3 says. From my studies, I have found that you can alter the energy of a photon by simply adding or subtracting energy from that photon. It doesn't mean anything. Adding and subtracting energy from a photon. That means compressing it or expanding it. Oh, okay. You know, the frequency of the quanta. What technique do you use for this? Obviously, you change the frequency. Just making that sound like it's some kind of big technical thing. You consider photons magnetic, but we don't see this happening in real life. So what exactly do you mean by magnetic? Yes, there's no evidence that you can bend a photon with magnetism, so clearly it can't have a polar, it can't be a dipole of any kind, and it can't be a charge of any kind. Is it just an analogy, or do you really consider them to be magnetic? Yes, and you're just using the word because somebody else connected those two things together and said that makes sense somehow, and it doesn't. So, yeah, can't make any sense out of that. All right, so maybe now it's enough. I do want to try to diagram this thing in terms of this, just understanding that each one of these things is just movement, right? I mean, heat is the movement of the atoms. You know, that's how we measure it. But it all equals the same amount. So you could convert those movement of the atoms themselves into the movement of the electrons. And then you can convert the movement of the electrons into just force itself. So it's like the same amount of force you can convert into heat. And it'll always be the same amount per density of atoms, you know, and that kind of thing. The more dense the atoms, the more heat will be expressed. You know, a smaller amount of energy you need to create heat, but you have more paddles to bounce the heat off of, the energy through. You know, it's all related, and it just has to do with converting one movement into another movement. Sort of like the Earth example I gave with gravity. So the force goes in as force, and it comes out as clumps moving. And so you could think of it as like the Earth is radiating pieces of stuff, matter, and that matter might travel billions of light years. Well, it can only travel those billions of light years if no other force acts on it, right? So you can always think of that external pressure is coming in, and if I send a bunch of the force out in pieces that keep traveling, that means it's not hitting any external pressure that's stopping it. So it's back sort of to the redshift argument, that you can sort of understand that even if I have a transparent atom moving and a photon hits it, the atom is going to slow down. It's going to absorb the momentum of the photon that hit it, and that was part of what was missing from the original Why Can't This Be True series of videos, where I got into this argument about that, is that nobody accounted for the fact that as the atom slows down, that's another effect of the photon hitting, and the process of slowing down. And that wasn't part of it. And you have to include all the pieces. You know, all these little bits have to be included before you can draw conclusions. You know, there's lots of facts to be aware of. So again, the real trick is, yes, we have limited information, but if we're careful, it's enough information, I would argue, to draw some conclusions with some confidence. Now, what level of confidence? You know, I'm just saying that some things I think we can discount. I can argue that I can discount ether merely because it makes no well, what, you know the word I'm looking for. Geometric? Alright, no geometric sense. You know, in the sense that if you make it out of particles or structure, it ends up being like a checkerboard, and the diagonals end up being a longer distance than the straight lines. You know what I mean? You can't make it out of something that doesn't end up creating this problem where the diagonal distance is longer, and all of the rays have to have the same ray length. And so you can't really do the geometry. You can't do circular geometry out of straight lines if you're making things permanent. I mean, if you're giving things a domino structure, you can't make the rays of dominoes be able to point in any direction. So the very fact that you can get to point A to point B in a straight line, I would argue you really couldn't if the ether had a geometry, because there might not be a straight line path. You might have to do a diagonal and then somehow undiagonal. And what would be the motivation for the photon to do that? There wouldn't be one. So it's kind of defeated by the bad geometry. That's one reason not to believe. The other reason is there's no reason to create a more complex mechanism than the thing moving through the mechanism. The board shouldn't be more complicated than the checker pieces that are moving through it. So if your board is more complicated than your force, you're fucked. And that's what I would argue against Bill Gates' rope theory, is that his ropes are more complicated than the matter. He's saying I have to make connections between every electron and every other electron in the universe, and there's two threads going from one electron to every other single electron in the universe, to make photons work, right? They have to be twisted ropes. I mean, just the number of ropes, it's a preposterous mass of rope to make something so tiny. It just doesn't make any sense. You can't make any sense. How could you even fit all those threads to it without being bigger than the thing is allowed to be? There's no continuity. The tiny photon is a twist of the rope, but the percentage of mass that has to the photons really do move electrons. So how could that one little twist matter if you are connected to an untold number of other connected ropes? It just doesn't, well, anyway, I can't make any sense out of that. As a starting point? No. As a finishing point? No. I mean, doesn't it just say reasonably there's just no reason to try to make ropes work? There's got to be a simpler mechanism. There's a reason to say that anyway. And yes, I believe the simpler mechanism can be described, blah, 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 blah. Alright, well, that's all I can do. Again, all I can do is make what I think are reasonable arguments, explain to you why this can be explained as simple process, not complex process, and attempt to explain why they haven't figured out how simple it is. But that gets into the whole psychology of humans. But anyway, so I'll try to evade that subject. I'm just saying, I don't know your resistance is difficult for me to understand. Why are you clinging to the complex, convoluted, virtual, bent bullshit theory when this simple mechanical thing just answers all the questions? So anyway, till the next time and such. Now I was going to do some drawing, but yeah, I'm just kind of tired. Yeah. So just waiting for something more biting, as either more challenging as a counter argument, and it's just not here. We're just not getting it. So I don't have anything to chew on much. But there's always work to do, so I could, I mean, I am doing that in a sense. I'm trying to gain some perspective of what they thought, 100 years ago, and why they thought it, and why people are attempting to keep resurrecting those wrong ideas. Dielectricity, for example. It's just a wrong idea. Look, originally they thought there were different kinds of electricity, right? I mean, they thought the fish that were creating electric shocks. There was a couple of different electric eel and some other dopey fish that electrocuted things. And they thought these things were, they thought that biological electricity was a different kind of electricity than the regular Leyden jar electricity and all that kind of stuff. Lightning was different than, and they didn't understand that the concept was electricity, which is the transfer of pressure between atoms, and that's electricity, and that's always the same. The sources can be different, but the effect of atoms transferring pressure, voltage, is always the same. And they thought it was a fluid, which is analogizable. I mean, I don't hate that idea. It's a flow. Certainly, you can certainly understand soldiers as flowing through a battlefield or something. You get that impression. So that's not all bad. But clearly, if you take it too literally, and they did. They basically were saying it's a flow of some kind of ether. No, wrong idea. All right. So even the Tesla thing is kind of funny, because Tesla did believe in a particle ether. And all these people keep thinking that Tesla was some sort of wooey ether. No, he said it overtly. It's made of little particles. So he was a particle guy. I mean, his autobiography is hilarious in the sense it's just a bunch of anecdotal stories about how he nearly died 400,000 times. And, but whatever. The eccentricities of individuals. But there's some wisdom in what he's saying about, disciplining the mind. He had all kinds of psychiatric issues. I mean, it really was a bit of a nutter. I mean, he saw visions that scared him, and he couldn't get them out of his head, and he had all kinds of demons, so to speak. And the good news is, though, he was still logical enough to know, well, how can I make this productive? How can I get something out of this rather than just turned into a lunatic? And so there's lots to be learned from that kind of experience of trying to understand your psychology. So, the whole idea of being a little bit introverted, which he was, and doing introspection. But what he turned it into was just like I said, he's just imagining himself always getting, he was so full of himself, as if he had, answered all the questions that need answering or something. He really was a little bit egotistical, or whatever the right word is for that. Had way too high an opinion of himself. But anyway, until next time.